Today we're going to be focusing on the color of light. So there are three colors of light, they're called primary colors, and those primary colors are red, blue, and green. I want you to understand that this is not pigments. This is not like when you're mixing crayons. This is with light, and light behaves differently than the pigments do, okay? So there are three primary colors of light. That's red, blue, and green. And every color after that of light, all you have to do is mix these three colors in different combinations and different percentages and densities or whatever, right? And you'll get all the other colors of light. So when we mix them, if they're the primary colors, if you just mix red with green, you end up getting yellow, okay? If you mix red and blue, you get magenta. And then if you mix green with blue, you get cyan. Okay, and you do have to have all of these memorized. Now, what's really interesting is actually if you blend all different colors of light, what do you end up getting? You end up getting white. Okay, so white light is actually the presence of all colors of light, which makes sense because when you break down white light, what do you end up getting? You end up getting the colors of the rainbow, which are all the colors of light, right? So it makes sense. All right, so these guys are called secondary colors. Secondary colors are, we've got the primary, which is red, green, and blue. And then the secondary colors are when you mix those two colors together, what you get. So that would be the yellow, the cyan, and the magenta. Okay, so secondary colors are when two primary colors overlap. What you really have to remember is this saying, okay? You read on the right, you read my book, Curious George, okay? Because you are going to have to memorize, if I mix red and green, what do I get? If I mix green and blue, what do I get? And if I mix red and blue, what do I get? And I personally don't think all of these are very easy to understand, especially like red and green. What? You get yellow? So here's how it goes. You read my book, Curious George. So if you write it out, you read my book, Curious George. Okay, we have our primaries. And then in between, if you combine, so if I combine red with green, I get yellow. If I combine green with blue, I get cyan. And if I combine red with blue, I get magenta. So as long as you remember, you read my book, Curious George, and you put it in a circle, you'll be able to figure out what the primary colors make to make your secondary colors. Okay? So these are called complementary colors. Complementary colors are, if you're on this color wheel right here, if they are across from one another, they are called complementary colors. What that means is that when you combine them, you end up getting white. So if I combine green and magenta, I get white. Okay? If I combine cyan, which is the secondary color, with red, I get white. Okay, and then if I do yellow with blue, I get white. And why is that? Well, remember, white light is the presence of all colors. Okay, and you're like, well, I just combine, let's say, yellow and blue. Why do I get white? That's not all colors, that's just yellow and blue. But if you look at what made up yellow, truthfully, it's not just yellow, it's actually yellow is a combination of red and green. So I am actually combining, when I'm combining yellow, I'm actually combining red with green to make my yellow, and then by adding blue, what do you notice that I've used all of? I've used all of my primary colors, which means when you use all your primary colors, what do you get? You get white. Okay, so once again, let's look at the complementary colors. So green with magenta would make white. Those are complementary. If they're on the opposite sides of the color wheel, they are complementary. All right, there's a few terms regarding light that you should be familiar with and be able to understand. Okay, first off, the word transmitted means that light passes through. Okay, and there's two types of transmissions that we will be talking about. One is a transparent transmission, and two is a translucent transmission. Okay, so both mean that light goes through it, but how do they go through it? Transparent is when light goes through it and it's perfectly clear. So like a clear glass window, that would be transparent. You can see perfectly through it. Translucent is where light lets it go through, but there's no details that pass. These are kind of like those shower ones, the shower curtains or whatever, where it allows light to go through, but you can't see through it, right? You can't see those details perfectly. That's called translucent. Transparent, perfectly clear. It's like a perfect window. Translucent, it's a little foggy. It's like fog glass. Okay, those are transmissions. Then you also have opaque. Opaque is where it does not allow any light to pass through. So that'd be like a door, right? So if I have a concrete door, well, who would have a concrete door? Let's say I have a wood door, right, without any windows, that would be opaque. No light's going through it. All the light is going to be bouncing off of it, right? So once again, we have two types of transmissions. You can have transparent and translucent. Right now we're going to be doing transparent. So it transmits light, okay, which means that all the light goes through. Okay, what happens though, which is interesting, is that light actually changes its speed while it is going through the material. You don't know, you have to know whether it goes up or down. It just does change its speed. Light also travels at different speeds when you're talking about temperatures. So just like sound travels differently, light also travels differently, okay, when you have different temperatures of an environment. And then color of the transparent object is the color that the light transmits. And we'll talk about that in the next few slides. Okay, so the color of the object that it's going through will allow only certain colors through. And that's what we'll talk about in the next few slides. Okay, and then opaque materials. So opaque materials actually absorb all of the light. So all the light is bounced back. No light goes through. Okay, and what actually happens, because light is a form of, it typically has the thermal heat, what happens is that energy is typically converted into thermal energy by being absorbed by that object. So by me putting a light on it, on an object that's not transparent, it will absorb a lot of that energy in the form of light and it will heat up. Okay, so these are just some examples: wood, stone, people, metal, of things that actually absorb light and do not allow it to go through. For this one, the color of the opaque material is the one that's reflected. It's a very similar idea to these. One is just reflected, meaning it's bounced back at you, and one is actually transmitted, meaning light goes through it. Okay, so this is just an image of the transparent, translucent, opaque from the two slides before. So we've got transparent where it goes perfectly through. We have translucent where the light goes through, but it's not a clear image. And then you have opaque where nothing is allowed through as far as light goes. All right, so this is when you have an opaque object, what is going to happen? So light is going to be reflected off, okay? So if we put all of these lights together, so red, blue, and green, which are our primary colors, if we shoot all of our primary colors, which means we are actually shooting white light at this, okay? So we are shooting white light at it, and it is a red object. The only color that will bounce off is something that is red, the red light. Okay, it will only bounce off the others. It will actually absorb every color that it is not. Okay, so this one is where you do all the primary colors and it's green, it will only reflect green. And then which one, where blue, the only one it'll actually reflect is its own color, which is blue. Okay, now comes into something a little bit more unique. So we've got cyan. Cyan is not one of these three primary colors. So you have to go to your little color wheel, cyan. And what is cyan made of? Cyan is made of green and blue. So those are the ones that will reflect. So cyan will actually reflect two types of colors. So red, and it'll absorb the red. So it will bounce off the blue and the green. If you look at magenta, magenta is made of red and blue, so therefore that is what it is going to reflect. And if you look at yellow, yellow is made of green and red, so what is it going to reflect? It is going to reflect its green and red and absorb all other colors. Okay, so this would be more of a where it allows the light through, so something that allows transmission. Okay, so we've got white light. We're going to break it down in this image of the red, the blue, the green. Okay, and now we're putting up a yellow filter. So this is like putting up sunglasses, right? That's yellow, or a yellow screen in front of you. Okay, so what is yellow? Yellow is red and green, so that's why it is only going to allow your red and green. But you're not going to see that because if I ever combine red and green, what do I get? I get yellow. So if I broke down the yellow light is when I would see the red and green, but I don't because yellow is red and green. So I would only see their mixtures. Okay, next one. We have white light. And so we are going to have all of our primary colors, but this time we are going to be doing magenta. Okay, and magenta, get rid of that. Magenta is a combination of red and blue. So that's the only things that it will allow through. Once again, we will only see magenta, but if we broke it down into their actual primary colors, you would be seeing red and blue. Next one, we have white light. So once again, that's all the primaries, but we are doing cyan this time. Cyan will only allow blues and greens through. So notice that we'll allow the blue and the green through, which means we will see that cyan. This one is a double filter down at the bottom. So we start with white light, which means we start with everything. If I put up the first filter, it will only allow yellow through, okay, or the colors that make up yellow. So what makes up yellow? Red and green. So that's why I'm going to allow red and green through. Okay, blue is knocked out of the game because I put up that yellow filter first. Now I'm going to put in a magenta filter. So when I put in this magenta filter down here, okay, magenta will only allow red and blue to go through, but blue has already been kicked out of the game. Now green is going to be kicked out of the game. So what am I left with? I am only left with red light, and that's actually the color I would see. I wouldn't see magenta anymore. That's where it changes it up. I would only see red, actually. The magenta filter would look red. All right, so let's try to describe this image, okay, using this color wheel. Remember, you read my book, Curious George, okay? Make sure you memorize that. Okay, so we've got white light. It is all the primary colors, okay? So we're going to put up a yellow filter first. Yellow filter means we've got red and green, okay? So we've got our reds and our greens. That's the only ones that are allowed. Blue is out of the game. Okay, so by putting in yellow, I only allow my red and green. Now I'm going to put up my cyan filter. Cyan filters only allow greens and blues, but blue is out of the game. And now what other colors out of the game? Well, red is out of the game because cyan will only allow blues and greens. So therefore, what am I left with? I am only left with green. Green is the champion of this one. Okay, let's describe this image. So we've got white light. Once again, all the primary colors. Put up a magenta. I only allow reds and blues through. Okay, green is out of the game. Now I'm going to put up a cyan filter. Cyan only allows blues and greens. So now red is out of the game. So what am I left with? I am left with seeing something that is of a blue light. All right, hopefully you understand how to use this color wheel. Really important. You read my book, Curious George. Okay, that'll help you with the orders. That'll help you with this thing a lot. And then make sure you understand out of this that reds, blues, greens are your primary colors. And then you've got yellow, magenta, cyan. Those are your secondary colors. And if you combine your primary colors, you get white light. And everybody asks, well, what's black? Black is the absence of light. Okay, so black is no light whatsoever. So the opposite would be all light, and that's where you get white. Okay, have a great evening. Hopefully you understand a little bit more about colors of light.